Here we are given matrix A equaling 3, 2, 5, and 3. We're trying to calculate the following. So A inverse squared plus A squared and the inverse of that. So keep in mind this is not quite the same as regular algebra, where the negative first power does not mean that you're taking 1 over the matrix. But what it does mean is that you're taking the inverse. So to find the inverse, what I need to do is first find the determinant of the matrix. So the determinant of this matrix you find by taking 3 times the 3, I'm going to get 9. Subtract that by the 5 times 10, multiply across, I'm going to get 9 minus 10, and that's going to give me a negative 1. So this is your determinant of that matrix. So to find the inverse, you're going to take 1 over the determinant, which is negative 1, and then times that by, now what you're going to do here inside the matrix is you're going to switch this number, the top left, with the bottom right. Now in this case it does not make a difference because they're the same number, so I'm going to get 3 there and a 3 here. And then what I do is I need to take this 2 and this 5 right here, and both of those are going to be the opposite. So if they're positive, make them negative. If they're negative, make them positive. So I'm going to get a negative 2 here and a negative 5 here. So when I multiply negative 1 over 1 times this matrix, what I do is just basically multiply every part of the matrix on the inside by negative 1. So that's going to give me a negative 3, positive 5, a positive 2, and then a negative 3 over there. So this is my inverse, and we are told to square this. So when I square this, it means I'm going to take that and multiply it by itself. So when I do that, I'm going to get negative 3, 2, 5, and negative 3 again. Multiply it by itself. And to do that, it's kind of a process to use where I'm going to multiply the first row by the first column, and the first row by the second column, and then the second row by the first column, and the second row by the second column. So remember to do this. When I multiply row 1, column 1, I take this negative 3 times this negative 3. I'm going to get a positive 9, plus this 5 times this 2 is going to give me 10. So positive 9 plus 10 will give me a 19. That's going to go right there in the top left. And we know where to put it because we're taking the row 1, multiplying that by column 1. So that's going to go in row 1 and column 1 of this new matrix. So to figure out the rest of the numbers, I'm going to take row 1 times column 2. So I'm going to get negative 3 times 2 gives me negative 6, plus 2 times negative 3 gives me negative 6. So negative 6 plus negative 6 will give me a negative 12, and that goes right there. Now, to find the other numbers, I'm going to take row 2 times column 1, so I'm going to get 5 times negative 3 is negative 15, plus negative 3 times 5 gives me another negative 15. So negative 15 plus negative 15 will give me a negative 30, which goes right there, because we have row 2, column 1, so therefore it's going to go in row 2, column 1. And then that bottom right corner, I find that by taking row 2 times column 2. So 5 times 2 gives me 10, plus negative 3 times negative 3 gives me 9. So 10 plus 9 will give me a 19. That's going to go right there. So this would be my A inverse squared. It's going to be this right there. So now I need to find A squared and then take the inverse of that. So I'm going to start a new page over here. So on this page I'm going to start with finding A squared. So A squared is just taking the matrix, multiplying it by itself. So here's what I'm going to get, and I'm not going to take the time to go through and show you the process again. I'm just going to show you what the numbers should be once you multiply them. But the process is the same that I used for matrix multiplication earlier for this problem. So I'm going to get, when I multiply, a 19, a 12, a 30, and then a 19. So now I need to find the inverse of that. So to find the inverse of that, I need to find the determinant first of all. So I find that by multiplying across 19 times 19, which that will give me a 361, and then a 30 times 12, is going to give me a 360. So 361 minus 360 is going to equal 1. So I use the determinant to find the inverse, so it's going to be 1 over the determinant, which is 1. So 1 over 1 will just give me 1. So I have 1 times, and then the new matrix that I'm multiplying by is found by taking this number and switching it with this number, so the 19 and 19. In this case, they're the same. It doesn't make a difference. So I'm going to have 19 on the top left, 19 on the bottom right. And then I'm going to make the top right and the bottom left negative. So it's going to be now a negative 12, and it's going to be a negative 30. So a squared, and then the inverse of that will equal finally 19, negative 12, negative 13, and 19. And now from the previous page, we found a inverse and then squared. We found that to be this matrix. And now finally, we are told to calculate the addition of these two matrices. So when I add these together, I'm going to add the corresponding parts. So the top left here, 19 plus a 19, will give me 38. So it's going to be 38, negative 12 plus a negative 12 will give me negative 24. Negative 30 plus negative 30 will give me negative 60. And then 19 plus 19 will give me a 38. So your final answer should be this matrix right here.